Welcome to our lesson on the application and tech section of the Chapter 2 pretest. So today I want to walk you through problems 26, 28, and 29 from the pretest. We already talked about number 27 when we went through polynomials and quadratics, and so we won't be talking about that again today. We're just going to talk about 26, 28, and 29. So let's get started. If you don't already have it out, I would suggest that you have your TI Inspire handy and that you have your TI Inspire booklet handy, because there are some things I'm going to show you on the calculator that may be helpful not only just in these types of problems but in other types of problems, and you may want to be able to take some notes over what I show you to refer to later. So if you need to, pause the video right now, get those things out quick, and then you can come back and continue. All right, so our first problem says the path of a baseball after being hit is given by the function f of x equals negative 0.0032x squared plus x plus 3, where f of x is the height of the baseball in feet, and the x is the horizontal distance from home plate in feet. And the question is, what is the maximum height of the baseball? Now, the first thing to do is to make sure we understand what is being represented by what. So we've got f of x here representing the height, and we've got x here, which is going to represent the horizontal distance, how far away from home plate you are. Okay? And then we have this equation that tells us how those two things are related. So the f of x, which is the height of the ball, is related to how far away from home plate you are given this equation, the negative 0.0032x squared plus x plus 3. Okay? Now it also helps if you just think for a minute, what kind of function are we actually working with? This is a quadratic function because we can see our x squared right there. It is a quadratic that is going to open down because we have this negative a value in front of it. And so just a quick sketch kind of gives us an idea that we're dealing with something that looks like this, which would make sense if we're talking about the path of a baseball. It makes sense that the batter hits it here. It's going to go up as it's going away. At some point it's going to come back down. And so this makes sense as a path of a baseball. Now what we're being asked to find is the maximum height of the baseball. So we're being asked to figure out what is this largest distance above ground level that the baseball gets to. Well, in terms of the parabola, this point is the vertex. So really this is a problem where we're simply trying to find the vertex of the function that we've been given. Now, one way to do this is algebraically. We can simply use what we've talked about to find our x value. So we should know that that is negative b over 2a. And if we substitute our numbers in, a negative b is going to be negative 1, and 2 times a is going to be 2 times negative 0.0032. Okay? And here's where our calculator is going to come in handy. If I go over here and just do a quick calculation, I don't need a new document for this. I want to take negative 1, and yes, I want that to be negative 1, divide that by, and I'm going to put this in parentheses to make sure it's all part of the denominator, 2 times a negative 0.0032. Hit return, and we get 156.2. Okay, so back here, the result I get from my calculation is 156.25. Okay, now again, what did x represent? Is this the answer we're looking for? Is 156.25 feet the highest, the maximum height of our baseball? No, x was the horizontal distance. So this represents feet away from home plate. This does not represent what we're looking for yet. So now we need to go back and figure out the y, or f of x, that we get with this value of x. So that means taking negative 0.0032 times 156.25 squared plus the 156.25 plus 3. So again, if we go back to our calculator for a quick calculation, we have got negative 0.0032 times 156.25 quantity squared plus 156.25 plus 3. Hit enter, and we end up with a result of 81.125. This is our y, or our f of x value, and so this is the maximum height that we're looking for. Okay, so one way to use the calculator in this case is simply to help you do the calculations, since these are not the prettiest numbers in the world. Excuse me, and we can just work it out algebraically to find our vertex for our parabola. And from that vertex, we can answer the question and say the maximum height is going to be 81.125 feet. Okay, but we could also use our calculator to either check this answer or to just find it in the first place in a graphical method. So I'm going to go back here to my home, and I'm going to choose a new document for this. We're going to choose graphs. And so for my f of x graph, I'm going to put in the function that I was given. We were given negative 0.0032 x squared plus x plus 3. Now, when I first look at this, it looks like I just have a straight line. Okay? But part of that is because of the scale I'm using. All right? We are just looking at this very small little piece of the graph when we know from the algebra that we're talking about x values that are up in the 150s and f of x values that are up into the 81 range. So in order to really see this full parabola, we need to change our window. So we need to go to the menu. We're going to choose Window Zoom. And when you put your cursor over that, you'll see there's all these different kinds of possible zooms that you can do. And you can play around with some of those if you like, but since I already have an idea of what kind of numbers I want to use, since I already did the algebra, I'm going to set the window settings myself. So I'm going to choose Window Settings. Now I'm not really interested in negative x values because I'm not interested in a negative distance from home plate. So I'm really just going to put in -1 just so that I'll be able to see the axes. Now for an x max, I'm going to put in about 300 because we know that the vertex is supposed to happen at an x value of 156. And so if we double that due to symmetry, we would expect that we're probably going out to about 300 for the x value. So that seems like a good x value to start with. I'm not going to change the scale at all. I'll let that just auto set. For my y values though, again, I'm not interested in negative y values because that would mean it would be below the ground. That doesn't make any sense. So again, I'm just going to set that to -1 so I can see axes. And then for my maximum y value, I'm going to set this to about 85. That way I'll be sure to see my 81.125 within that, and it gives me a little extra space. Again, we're not going to mess with the y scale, and so now we're going to choose OK. Now you can see the full parabola, or at least a good portion of it. And you can see here is the region where the vertex is going to happen. We really do have a parabola that opens down. And so now I can go to my menu and I can choose to analyze the graph. And notice that I have choices like 0, minimum, maximum, intersection. Well, if I want the vertex on a parabola that opens down, I want the maximum point. So I'm going to choose the maximum, and then I'm asked to set the lower and upper bound. So I'm going to set the range that I want the calculator to look in to find this max point. So I know it's in here somewhere, so I'm going to just set this where I know it's going to be lower than the vertex. Then I have the question down there in the box about being an upper bound, so I'm going to move it to the right. And you'll notice that once you pass the vertex, you'll actually get a little sign there that says, whoop, look, you've hit the maximum. And so you just need to make sure that this other boundary line is somewhere to the right of that. Click again, and now you have your labeled point. And so you'll see it's 156, which is our 156.25 rounded. And then you've got 81.1, which is our 81.125 rounded. So you can either use this method as a way to check your algebra, or if you're really not sure about how to do this algebraically, you could go and just do this graphically in the first place to at least get an idea of what your answer should be. Okay, so that's how we would want to tackle question number 26. All right, moving on to question 28. Remember, 27 is the one we're going to skip. So question 28. Now, if you remember, I asked you to omit part B because it was not written correctly for what I actually was hoping to do with that problem, so we just skipped it altogether. So we're really just interested in part A and part C. So in this case, we're told that you are designing candle making kits. Each kit will contain candle wax and a mold for making a pyramid-shaped candle. You want the height of the candle to be 2 inches less than the length of each side of the candle's square base. Now there's a lot of really good information just right there in that last statement. And sometimes it helps if you just draw yourself a little diagram. Okay, so we know we've got something that looks something like this. Okay. We know that we have a square base. So whatever this side is what this side is. Okay, we know that we have a height on a parabola, and that we want this height to be 2 inches less than the length of the side of the candle squared base. Okay, so if we go to part A, we're reminded that the volume of a pyramid is V equals 1/3. Capital B, remember, stands for area of the base times the height. And we're asked to write an equation for the volume in terms of x, which is the length of the side of the square base. So up here, because we're told that the height should be 2 inches less than the length, instead of labeling this h, we want to label it x minus 2. Okay? That way everything is in terms of x, and we're not dealing with anything that has excuse me, more than one variable in it. All right, so now if we use these dimensions and we use this formula, we should be able to substitute in an expression for the area of the base. My base is a square with sides of x, so the area of the base should be x squared. And then times the height, and we've just said the height is 2 inches less than the side of the base, so the height is going to be represented by x minus 2. Okay, this is what part A is asking for. It's the equation that represents the different possible volumes based on how big your base is going to be and what the height is going to be in comparison to that. Okay, then we skip down here to part C, and part C says find values of x such that the volume equals 25 cubic inches. Are all solutions possible in the context of this problem? Explain. Okay, so we're now taking this equation and we're putting the 25 in for an actual volume. So we've got 1/2 x squared and x minus 2. Okay? Now, in order to solve this, to find the solutions when we actually have a specific volume of 25, there's a few things I can do here. First of all, I'm sorry, this should be 1/3. My mistake. There we go. And this one should have been 1/3. Okay, 1/3. All right, so one thing I can do here first is get rid of this fraction. Fractions are always messy, they sometimes will confuse us, and so let's just get rid of it. How am I going to get rid of the fraction? Well, remember, I can do anything to an equation as long as I do it to both sides. So, if I multiply this side by 3 and multiply this side by 3, then I can multiply in any order because multiplication is commutative. And so the 3 times the 1/3 will cancel each other out. The 3 times the 25 here just becomes 75. Okay? And then the other thing I can also do is distribute my x squared here so that I can get rid of the parentheses. So I actually have terms that I can work with. So this is going to be an x cubed and a minus 2x squared. Okay? And so usually when we're talking about polynomial kinds of equations, usually we want everything on one side equal to 0 in order to figure things out. So I'm going to go ahead and subtract my 75, and that's what we're working with. All right, so now what? Well, again, here's where the calculator can come in handy. This is not necessarily going to be a super easy equation to solve. It doesn't factor. It's not in a quadratic form. It's not something we can use grouping on. And so when that's the case, if you're on a section where you can use your calculator, go to a graph. Let's put in a new page here, Control, Doc. Add another graph page. Okay, let's take a look at what the graph of this would look like. So we've got x to the third power minus 2x squared minus 75. Now again, at first glance, this is not a particularly helpful graph because when we look at this, it looks like it's just a straight line through. Well, again, it's probably because we're only seeing a very small part of what the graph actually looks like. So this time, when we go to our menu and we go to our window zoom, let's just do a zoom out. And let's make the center right here. Okay, so we're seeing that. Let's make the center down here a bit. And maybe down here a bit more. Now we're starting to see it. Now in order to get out of this, let's go down just a little bit more. There we go. In order to get out of this zooming magnifying glass, we just need to come up here to this little icon on the upper left corner. Click on that. Oh, my bad. Control, escape. We'll go back a step. There we go. Let's see, I thought it was click on the corner. Click the center of the desired viewing window. Yes. How about a control click? Nope, that doesn't do it either. Let's go back, control escape. How about just escape? There we go. So hitting escape gets rid of the little icon up here and gets rid of my little magnifying glass. So now we can see that we've got this little S curve where it flattens out right about there and then keeps going down on this side. So we can see where that cubic shape now is. But what are we really interested in? We're interested in when this cubic equation is equal to 0. So for what x values will I get an answer, a y value of 0? What that means is I'm looking for the intercept. Now if you noticed when we were zooming, before we started zooming, you might have counted what the intercept is. Now that we've zoomed out, it's a little bit tough. So we're going to zoom back in. Okay, and hit my escape to get out of there. And it looks like we have an x-intercept at 1, 2, 3, 4, 5. Okay, now to check that, we can go back to our algebra and we can do some synthetic division. We can check the 5 out here. Make sure that when you set up the coefficients that you remember to include 0 for the x term that we're missing here. And then we'll bring down 1, multiply to get 5, add to get 3, multiply for 15, add and get 15 because it's just adding to 0, multiply to get 75, add to get 0. So it does show that 5 really is one of the roots, and it gives us x squared plus 3x plus 15 as a result. Now if we take this and try to solve it, Since there are no factors of 15 that are going to add up to 3, I'm going to try quadratic formula and see what kind of answers I get. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Notice what's happening in our determinant here inside of the square root. A 4 times a 15 is going to give me 60. A 9 minus a 60 is going to be negative. So I can get some imaginary solutions out of this, but in the context of the problem, do imaginary solutions make any sense? Am I going to be able to pack this kit based on imaginary number x values for the side of my square base on my pyramid? I think the obvious answer is no. So we don't want to consider these answers, these imaginary answers. The only answer that really works is this x value of 5. And to answer the part about are all solutions possible in the context of the problem, explain, the explanation is these give you imaginary solutions. And that does not make sense as sides of a square. Okay, so the only value that actually does make sense is that the side of our squares, the sides of our square base, would be 5, and that would give us a height then of 3. Okay? All right, last problem, number 29. So number 29, we're told that the revenue and cost equations for a product are R equals X times 60 minus 0.0001X. Okay, so that's revenue. And the cost, C, is 12X plus 1,800,000. Where R and C are measured in dollars, and X represents the number of units sold. Okay, so if we sell X units in this equation, this is how much revenue we're going to make, how much money we're going to bring in. If X is the number of units sold in this equation, this is how much it's going to cost to make that product. Okay? All right, continuing on, it says if profit is the difference between revenue and cost. So profit equals revenue minus cost. You bring in the money, you pay all the expenses, whatever's left over, that's your profit. Okay? So if profit is the difference between revenue and cost, how many units must be sold to obtain a profit of at least 3,600,000? Okay? So basically we're going to start plugging things into this simple equation. We want a profit that is 3,600,000. We are going to get the profit by taking R minus C. So for my R, I'm going to go ahead and distribute this as I write it out. So the X times the 60 will be a 60X. And then X times minus 0.0001X is going to be 0.0001X squared. So that's revenue. And we're going to subtract from that the cost of 12X plus 1,800,000. Okay? All right, so again, what are we really dealing with here? Well, we can see that we have an x squared term, we have x terms, we have constant terms. So this appears to be some sort of quadratic. So we would expect to see a parabola from this. Because it is quadratic, that gives us a hint that we're probably going to want to get everything on one side equal to 0 on the other. That's how we usually set up quadratics to try to solve them. And we're going to have to watch this minus because the minus is going to be distributed to both the 12x and the 1.8 million. Okay, so we're going to combine all this and move it all over to one side, and I would suggest, since our x squared term currently has a negative coefficient in front of it, that we actually move everything to the left side, which will give us a positive coefficient. Sometimes that's just a little easier to deal with. Okay, now that's one way to do it. Okay, and that's the way we're going to proceed here for the next minute or so. But I'll show you another way where you wouldn't even have to do that in just a minute. Okay, but let's go ahead and solve it like it's a quadratic now. So I'm going to add my x squared term. Then I have a positive 0.0001 x squared. Okay, takes care of that. I'm going to combine my x's here. So 60x minus 12x is 48x. And then I'm going to move it to the other side so I get a minus 48x. Takes care of those two. Okay, and then I need to remember this negative also gets distributed to this 1.8 million. So the 3.6 million I have here, I'm going to add a 1.8 million to end up with 5.4 million, or 5,400,000. And that's all equal to 0. Okay, so we've got it all on one side, but that's still not a very pretty equation to try to solve. So let's go to the calculator. Once again, we can go to our graphs to help us. So if I graph 0.0001 x squared minus 48x plus, there we go, 5,400,000, and hit enter. At first you may think that you've made a mistake. You don't see anything. Nothing is showing up. What did I do wrong? Well, you didn't necessarily do anything wrong. Again, you're only seeing a very small part of your graph based on the kinds of numbers we were using. So you're going to need to go and make some adjustments. Now, if you think about it, let me go back to my equation here for a second. I have just written an equation that has a y-intercept of over 5 million. So it should not be terribly surprising that I'm not seeing anything from 1 to 7. Okay? If I'm looking for solutions, okay, we've set everything equal to 0. Set everything equal to 0, and I'm looking for solutions that are going to make this equation equal to 0. Then that means I'm looking for x-intercepts again. So the first thing I'm going to do is I'm going to adjust my window. And for sure, I'm going to adjust my window so that my y values are going to go from let's say a negative 1,000 to start, up to a positive 6 million. Now I may need to adjust this. I'm totally guessing at this, but based on the numbers that I'm using, these are numbers that maybe make sense. Okay, now for my x's, again, I don't know that negatives really make much sense, so I'm going to just leave that at negative 10 for right now. For an x max, let's go 500. Just see what happens. If it's big enough, if it's not, we can always come back and readjust. Okay, am I seeing anything? Well, I seem to have this straight line right here. Doesn't seem to be showing me much, but I do have this line. Okay, so maybe the problem is I don't have enough difference yet. So we go back and we readjust. Okay, so maybe instead of 6 million, I'm going to go 10 million. And maybe instead of going to 500, we go to 5,000. Okay, are we starting to see things? A little bit. We're at least starting to see that it's coming down a bit. So I don't think I need to go up any higher because it appears like this is going to come down. So that means there's got to be some number way out here somewhere where this is going to cross. And 5,000 doesn't seem to be doing it. So let's keep going. Window, settings. Let's try 50,000. Well, I'm getting closer. See how it's curving down now? Okay, but 50,000 is still not quite enough. Try again. Let's try 500,000. Aha! Look at what's happening. And if I want to just, at this point, because I see enough of it, I can simply move my graph around. I can just, out here in white space, click and drag. And this will move my graph around a bit for me. So when I was like this, I can move it up to actually see the entire dip. So I can see that I have two different intercepts. I can see that I have a minimum somewhere in here. But what I'm interested in is the intercepts. So now I'll analyze. Menu, analyze, and I want zeros. That's what x-intercepts are called, or roots are called. They're called the zeros. So again, they're going to ask you to set up the bounds. So I set up a lower bound, I set up a higher bound, and there's my first possibility. But it's not my only possibility, so I'm just going to move this label up a bit so it's out of the way. And now I'm going to do the same thing. Menu, analyze, zero, and go a little bit to the left and a little bit to the right, and there we go. Okay. So according to this, I can make 1.8 e plus 5. Well, what does that mean? Remember, on the calculator, if you get 1.8 e plus 5, that is equivalent to 1.8 times 10 to the 5th. That's how calculators write their their scientific notation. Okay, so anytime you see this e between some decimal and then some positive or negative integer, it's the calculator's way of telling you that it's scientific notation and we need to take 1.8 times 10 to the positive 5 power. which means it's 1, 8, 0, 0. Oops, sorry, let me try that again. 1, 8 is the first spot. 1, second, third, fourth, fifth spot. It's 180. Our other intercept was at 3e to plus 5. Whoops, sorry. So if we have 3e plus 5, that means 3 times 10 to the 5th. That means 3, 1, 2, 3, 4, 5. Okay? So based on our equation, we actually have two possible results. We could have 180,000 units, or we could have 300,000 units. And if we want at least the 3.6 million, then we want to have profit that is bigger than that. Let's see, let's make sure we do this right. Because we turn things around, right? So we actually want the profit, we want the units that are in between there. Right? Because this is where we're actually going to get maximum profit. We just turned our equation around, which is why it's opening up instead of down. Okay? So if I want at least the 3.6 million, I've got to do anything in here. And you could pick some x values, put it back into your equation, and make sure that it worked. Okay, so pretty much anything between 180,000 to 300,000 would work. And I know that's a little bit different than what you saw in the answer key, because in the answer key I only had the 180,000, but as I'm thinking through it again, working through this with you now, it really should be anything in between those two numbers. Now, I told you I would show you another way that you could think about this without actually having to set up this quadratic. We can actually go right back here to what we started with and figure out the answer just from that. And let me show you how. Let's add one more page here so we don't get all cluttered up. All right, so we said that we needed to take r minus c in order to get at least 3.6 million. So let's take the r minus c and let's just type it the way they said. We're not going to work anything out except to go x times 60 minus 0.0001 x, and then we're going to subtract, and I'm going to put all of this in parentheses, 12x plus 1,800,000. Okay, what didn't it like there? Let's try putting a time sign in there. Okay, so again, we're not seeing it, but it went, it likes it. Let's leave it for a second. But now I'm going to go in and put in a second function, and this time the function is for the 3,600,000. Right? That's the threshold that we're trying to meet. We want our profit to be at least 3,600,000. So I'll put that in. Okay, so now we're going to go back to the window, and this time I already have a pretty good idea what the number should be. So we're going to use those. X, we're going to go from negative 10 up to the 500,000 that we were at, right there. And for min, we're going to go from, oh, let's say negative 100 again, up to, what did we say, 100,000? Let's see, no, we said 10 million, right? There we go. Those are the numbers we used. All right, so I have plenty of space here, so I'm going to move things up a little bit. So here's what's happening now. The pink represents our parabola that we get when we take the revenue minus the cost, right? That's what we have here. The green represents that 3,600,000 threshold we're trying to make. And so in order to find out where pink gets up to at least the green level, we can do another analysis, but this time what we want is the intersection. So we go a bit to the left, we go a bit to the right, we see we get an intersection at the same place, the same x value that we got when we solved it the other way. Okay, do the same thing over there. Analyze, intersection, left, right, and there's our 300,000. So there's 180,000. There's our 300,000. So I get the exact same x values that I got the other way. And now it's a little more obvious to see that what I want is this little bit of section right here, because this is where profit, R minus C, is going to be greater than this green line, which represents our 3.6 million. Okay, so we get the same answer. We're still looking for this interval between these two x values as being anything in there is where my profit's going to be bigger. Okay, and we didn't really do anything algebraic with that. We simply put in the R minus C equation, we set the threshold that we wanted, and we used the graph to find it. So these are all little tricks that you can use when you are dealing with problems where you are allowed to use your graph. You can use the graph to check your answer, to see if your graph confirms what you got algebraically, or you can just use the graph flat out if you're not really sure about how to do it algebraically. But if it's on a section of your test where you are allowed to use the graph, think about what's going to be more efficient and how the graph can really help you. It's not just about making calculations. All right, so I hope that helps you with those application types of problems and how to use the technology to your advantage in those problems. If you have any questions on any of these, rewind the video, go back to sections that you need to see one more time, go back to sections where you want to make sure you got those notes down correctly, and then any remaining time you have left during this period, I would suggest that you go back and maybe rework those pretest problems on your own without looking at the video. Make sure that you're doing some of the practice problems that are listed on your checklist that correspond with some of these application types of problems. Use your calculator on them, and make sure that you really have a good handle on this. Our post-test will be next class. So make sure you're ready. We'll have a few minutes at the beginning of class to ask questions, but it won't be a lot of time. So make sure you're ready, help each other out, and I will see you next week after we get back from Taipei. Have a great weekend. We'll see you next week.